All right, this is the third video to help you understand your project on cracking the code. On the message number 3, you have a quadratic equation that you need to find the inverse of. And this looks a little more intimidating. And it also is a little bit more challenging, especially when it comes to order of operations. So I wanted to walk you through a couple of that look like this. And for the quadratic equation that you're seeing right now, first of all, I just want to practice finding the inverse. Okay? So just like with the linear ones, we're just going to substitute x for y and y for x. So just change them. And now we are going to solve for y, all right? The first thing that I want to do is I want to isolate the square. So here is my square. So I just want to get that all by itself, and then I'll undo that square. So I want to get rid of this other term, -3, so I'm going to add 3 to both sides. So now those are not like terms, so this is x plus 3 equals 2 times the quantity x minus 3 squared. And again, I'm trying to isolate the square term. So this is the thing I'm trying to isolate. So now I'm going to undo this multiply by 2. I'm going to divide by 2. And I'm just going to, none of that can simplify, so I'm just going to rewrite what I've got left. I've got x plus 3 over 2. The 2's on the right-hand side cancel, and I've got equals the quantity y minus 3 squared. So now that I've got this square by itself, now I can undo the power of 2, which is the square root. So I am going to now take the square root of both sides. And when you do that, you might remember that you have to do plus and minus. All right, so I'm going to rewrite what's left. I've got plus and minus radical x plus 3 over 2. And on the right-hand side, the square root undoes the square. So I just have y minus 3. And only one step left. I need to get y by itself, so I am going to undo this subtract 3. I'm going to add 3 to both sides. And in the solution to a quadratic equation, we usually put that 3 in front of the plus and minus. All right, so this right here is the inverse to that quadratic that you were given. All right, we're going to do one more of these, but I'm going to do the next one just like message 3 is on your project. Now, basically what I've got is my own message and my own encoding function. So you should write all of this down, and then you can refer to it when you are doing your message 3 from your project. Okay, so the first directions are find the inverse of the encoding function. So I'm going to take this equation, I'm going to substitute x and y, just switch x and y around. And now I want to get the y, or the square all by itself, just like I did in the previous example. So all of this is what has to be isolated. So first I want to get rid of the term, the separate term that's on the same side. I want to get rid of 5. I'm going to add -5 to both sides. So this is x minus 5 equals 4 times y plus 2 squared. Of course, the 5 cancels. That's what I wanted to do. Now I want to get my square term by itself. So here again is what I'm trying to isolate. I'm going to leave that where it is, but undo this multiplied by 4. So I'm going to divide by 4. So this now becomes x minus 5 over 4 equals the quantity y plus 2 squared. Once your square is isolated, then you can undo that operation. So the opposite of square is square root. I'm going to square root both sides. Don't forget your plus and minus as you're doing that. And I'm going to rewrite what's left. Plus and minus the square root of x minus 5 over 4 equals, the square undoes the square root, y plus 2. Last step, get y by itself. I want to get rid of add 2, so I'm going to subtract 2 to both sides. And so now this number that's up front is negative 2. Plus and minus the square root of x minus 5 all over 4. So that is my inverse function, or my decoding function, for this message. Okay, so on my next screen, I brought over the same answer that I've already gotten when I did that for you on a different page. There's the decoding function. And here what I've got are these really big numbers. Oops. I'll move that over so that I can bring my calculator up. All right, so I'm going to start with my first big number, that one. All right, and I'm going to do these operations that are in the decoding function one at a time. So the first thing that's happening here is I'm going to subtract 5 from that number. All right, so I've got 2, 6, 0, 5, 6, 4, 1, 6, 9, subtract 5, enter. Okay? After I have that answer, I want to divide that by 4. Divided by 4. Okay. After I have that answer, I want to take the square root. Square root, okay, of my answer equals 8,071. Okay. And then after I have that number, I want to add a negative 2 to that. I'm going to add a negative 2, which, by the way, is the same thing as subtracting 2. So that's 8,069. I'm noticing that this video is getting longer than I was hoping for it to be. So I think that I'm only going to decode just that first group of numbers on the video. Okay, so here is that 8,069. Okay, and those, by the way, are the decoding of the other numbers that I decided to save time and not do them one by one. Split the 4-digit numbers to obtain the 2-digit Unicode. Okay. So instead of 8069, I've got 80 space 69. I've got 65. Instead of 65, 67, I'm going to make it 65 and 67. Then I've got 79 then 67, and then I've got 75 and 32. And then I'm going to use the Unicode from the first page of the project to see what those numbers mean. So 80 means P. Are there any other 80s in this problem? No. Let's see, 69 means E. There's no other 69s. 65 means, excuse me, 69. 65 means A. And there are two 67s, so 67 is C. Okay, so that is what you have to do to decode message 3. In the last page, you have to create your own message, write a quadratic function. When you write a quadratic function, try and keep it in this form. All right, that's going to make it easier for you. Just substitute in your, this is vertex